So after taking the basic measurements of some fossils, let's say brachiopods for instance, you're going to save it and you're going to document it in an Excel file and save it. And if you can see at the top here, I always put my first data in, the stuff that I measured. I name it whatever I did. So this is locality 10D. I called it sample, but I always call it raw because this is the raw data. And notice here that I have the specimens numbered, and then I have the length, width, and thickness, and all of the various measurements in millimeters. The little cell right here is empty because the width could not be measured for specimen number 7 because it was either broken or crushed or embedded in sediment. For whatever reason, it couldn't be measured. We'll get to that in just a little bit. But one of the things we're going to have to do now is try to get at a few sample statistics, and the first thing we need to do is create a few more columns here. And so we're going to create a column called LXW, length times width, and then the square root, SQRT, and then L times W times thickness, the length times the width times the thickness, and then the cube root. Now, to do these things, you need to, in this column, in this row here, row number 2, you insert Excel formula to calculate, and then you want to fill down. So for length times width, how we would do it for this first one, you put the equal, then parentheses, and then we want to multiply the number in cell B2 times C2, so we do B2, and then the little asterisk is the multiplier here, then C2, close the parentheses. If you hit return, there's the number. Now if we want to do this for all of these, you don't want to type that in over and over again, B3 times C3, etc. So you highlight the whole column right there, but not the title part up here. Go over to the far right of the Excel spreadsheet, hit fill and do down, and blip, there they all go. Notice that this column is 0 because length times no value is 0. We'll get to that in just a second. Square root. To do the square root, the formula is a little bit different. Excel has a whole bunch of set formula and ways to write them out. And the reason I chose the SQRT is because that's how we do it. So it is SQRT parentheses, and now we want to find the square root of this column right here, this column E, so this would be E2, the square root of E2, and hit return, and so the square root is 10.19637. So obviously that number multiplied by itself will give us this 103 value. To fill the columns, we do the same thing, highlight them all, go over to fill, hit down, it fills. Let's do this length times width times thickness, and if you kind of see what I'm going through, you are setting how I set it up before. Now I'm going to have equals parentheses B2 times C2 times D2, those three right there. Hit return, it fills it in, highlight the column, go to fill, down, fills it up. Cube root's a little bit different. You need to put the equal sign, and now we're going to want the cube root of this column here, column G. So we'll put G2, and then the root symbol for these Excel formulae is that little caret. I call that the caret symbol. It's sort of the little value when you do Shift key 6 on your keyboard. Then parentheses, and then because we want the third root, we do 1 third in parentheses right there. Hit return. There it is. Highlight the column again, go to fill and fill it down. There it is. Because I want this to be outlined again, I didn't show you this at the beginning, but I'm going to show you now. Highlight the whole thing, go to this little box up here for the borders, and put all borders in there. If you don't have it, it makes it hard to follow across huge Excel spreadsheets. Do this and you're all right. Now, one thing you can see here is that for number 7, fossil number 7, we have so much missing data, and then we have that one missing data there, and then all of these are 0. We're going to highlight it and delete it. Highlight it and delete. It's data that we're just not going to use. Now, if we were going to just look at the length of the statistics for the length, then we could use it. But for using these length times width and length times width times thickness, it's not going to be of any use for us. So now we've got this sample, and I go ahead and I call this, let's save it, save as, I'm going to put it on my desktop, and I'm going to call it, instead of raw, I'm going to call it, working, and because I already have a working there, let's call it working version 2. Save it. So now we have this group right here. Now, one thing we can do, another thing, is to get the averages, the means of all this data. And so I can highlight everything. Notice I didn't highlight the numbers here. Doesn't do any good. And if you go up to the pull-down menus at the top, there's this one, Formulas. And if you go to Auto Sum, click the little triangle at the bottom. And if you hit Average, it populates all of those with the averages of each of those columns. Now, I typically leave these averages hanging at the bottom, not enclosed in borders, just as sort of a way for me to mark that these things are separate, and they are the means of the columns. They're not the data or the various calculations of that raw data. Now I'm going to want you to open up the PAST program. So let's drop this down for a second. Here's my PAST 404 icon. Let's get that program open. Let's expand it. And what I'm going to do, let's go back to our Excel file here. I'm going to take this column right here. So, and I'm going to copy it. Now notice I didn't copy the name of this column and I didn't copy the mean. Let's click copy. Let's go bounce back to this one, put it here, and then for these you can't just right click and paste. You go to the edit button, you hit paste, and there it is. I'm going to do the same over here with this cube root data. Copy, and let's put it in column B and paste that. Now, notice this calls these columns A and B, but I'm going to rename them, and to change, if you want to change the names of any column or any row, you click on these buttons here. So I'm going to click Column Attributes, and I'm going to change the name of A to SQRT, and this is for sample 10D. And then I'm going to change the name for column B to cube root 10D. Then click it off, it bounces back, and you see we've named then, I don't want that. Just want it to look good. So there's the cube root of 10d. Now, we want to take this data and look at this. And so what I want to do now is to say, well, here's a bunch of measurements. This square root thing, this is actually called the geometric mean of the length times the width, so of those two characters. The cube root is the geometric mean of the length times width times thickness. You can just look at the mean of the length and then the mean of the width and then the mean of the thickness, but there have been several studies showing that the geometric means, where you multiply these things and then take the roots, gives you a better, more rigorous sample test. But we still want to look at this and say, now, okay, here's a distribution. Here's 7 characters, 7 characters. Is this data normal? Does it have a normal distribution? And so for this, you go up here to univariate, click univariate, and then notice if you scroll down, there's normality tests. Click it. Oops, I didn't highlight the 2 columns. Let's highlight the 2 columns. Now do that. Normality tests. And there they are, a whole bunch of these things, but I'm going to tell you which ones are important in just a second. Go ahead and copy it, and then go back to the Excel file, and go a couple down here below the Excel file, and paste it. Paste that data there. Because I want to read these things a little bit bigger, I can expand the... this way. What's particularly important, there's a bunch of different tests here, but for these, I'm going to make them colored because I want them to stand out. The test that I like the best for testing whether your data is normal is the Shapiro-Wilk W test. And this row 15 here, the P normal, that is the P test for whether this is a, the p-value, excuse me, for whether this is a normal distribution. We're looking for whether the numbers are less than 0.05. That would tell you that this is indistinguishable from normal, but these numbers are well over 0.05. They're 0.75, 0.89. This data is definitely not normal. Why we want that to know that is because that's going to then determine what tests we can use subsequent to this. Okay, so we've copied it and placed it there. I'm going to do the same thing. Highlight this and click the all border symbol. So we've got that below this. So here's our working file, the data. Here's our test of whether this data is normal. Let's go back then to the past. You can just get rid of that now. Let's go back to the past file. These same 2 columns are still highlighted. Now I want you to click univariate again, and this time go to summary statistics. Click it. The data immediately pops up. All these values, the minimum, the max, the sum, the mean, the median, etc., etc. Click Bootstrap. This gives you the upper and lower confidence limits for the values that were calculated. Go ahead and copy it. And once again, go back to the Excel file. Go a few rows down and paste this. And here again, you can see that what we've done is we see this column here, remember, is the square root of 10d, which is the geometric mean of length times width. Here's all of this data. Then we've got the cube root. Here is this data. I'm going to highlight this one, and I'm going to highlight this one. Now, Now for the mean, if you can do a quick check here. So like the mean of the square root of 10d, look at that, 8.932793. And if we go back up here to this original data, we've got the mean of the 8.9 of square root, and there's the value. So this was calculated by Excel. This was calculated by the PAST program. So they're the same. It's just a quick check to make sure these are the same. If the data were normal, which it is not, then we would work with the means. But we're not going to work with the means. We're going to have to work with the medians, with what is called non-parametric statistics. It's just a different set of tests. They're not as rigorous, but they still can test various hypotheses that we want to test. So before I close this one off, I'm going to go ahead and again make this the all border thing right here. And you see now we have, and I'm going to change this. Let's no fill. I highlighted the whole column and I don't want to do that. Let's make it look better. Let's just highlight the mean right there with yellow. And then the medians right there with yellow. And there you have it. This is the first part of what we need to do. So we've taken the raw data, the measurements that we've made on all of our various specimens, and then we calculated the geometric mean of the length times the width, and then the geometric mean of the length times the width times the thickness. If we measured 10 other things, then we would look at the root to the 10th power. But we're not going to do that. So typically for brachiopods and clams and snails and things like that, you'll measure maybe 3 things, and it's usually something like length times width times thickness. We got the means of those, and then we took that data, dropped it into PAST to see whether or not our data is normal. Did a quick test. The Shapiro-Wilk test definitely says that these data are not normal. These values are greater than 0.05. So we're going to have to use certain tests and eliminate other tests from consideration. We then took that same data again in the PAST program and highlighted it and got just the summary statistics, and then this spit it out right here, and I went ahead and highlighted the means and medians for you. This is the end of the first part. And then the next thing I'm going to do is I'm going to say, well, what if I want to compare the raw sample of this locality, so let's say 10D, to a different locality, 10E. What if I want to compare these numbers? Well, then I need to use a bunch of different tests, and I need to use the PAST program a little bit more than the Excel program. So I'm going to close this off now. Don't forget to save, and that's it.